Hello viewers, welcome to the Fundamental Physics by Issue classes. In this last video of electricity concept 4, I think in that we just understand the resistance when connected in series. So now we're going to understand resistances are connected in the parallel condition. See what is a parallel, meaning that when two or more resistors are connected between the same points, okay, are connected between the same. Suppose that this is the 2 points A and B. In this point only we will connect one resistor, again one more resistor, again third resistor. How many resistors we want to connect? All the points, all the resistors we are going to connect the between the only the same end points. But in case of series, how we connected? No, it is connected end to end. One resistor like this, again one more resistor, third resistor, and the last we are going to connect it that free ends of that all the resistors to the battery like this. But here we are going to connect between the two ends again, but that between the two ends we are going to connect the battery also. So you can see in a parallel lines like that here, instead of lines here resistor will be connected like this. So that is what we call this the parallel resistor. Series means in a straight line and parallel means in a parallel manner like this. So when the resistors are connected between the same points, they are said to be connected in parallel. Hope this is clear, children. When number of resistors are connected in parallel, then the positive potential difference across each resistor is same, at which the equal voltage and battery is applied. Suppose we applied a potential difference of V. Okay, let us rewrite this figure clearly. Okay, let us take R1 and R2 and R3. We have to connect all this to one end point. And this side, all this we connected to same end point, and that end point we connected to battery. Okay, of potential difference, let us think V. Here V1, what is the potential difference between these two ends of first resistor and the second resistor V2, and for the third resistor potential difference is V3. So all this potential will be equal to the applied voltage only. In case of parallel, V1 is equals to V2 is equals to V3. Okay, that will be happen. And current, no, what is the passing the current, that will going to divide. Okay, that is I1, I2 and I3. Current is going to divide, but voltage is common. What we applied voltage, that voltage will only maintain for all the resistors. Okay, children. A different amount of current flow. Okay, I1, I2, I3 flow through each of resistor, which depend on value of the resistance. Here 2 ohm is there or 4 ohm is there. The product of this two gives is volt potential of this. Okay, equal to the current flowing through circuit as a whole. Thus, when the number of resistors are connected in parallel, then the sum of the current flowing through all the resistors equal to the total current. So, total current will be equals to what? Current flowing I1 plus I2 plus I3. Again, all will come and meet. No, it will come equal to I only. So, here and here I we can represent, and along the resistors we are going to represent I1, I2, I3. The sum of these old currents that will be equals to total current. Okay, in the circuit. This is about the parallel combination. You need to understand here one point. Parallel combination means we are going to connect the same end point. All the resistors are given resistance. We are going to connect the same end points. That is the one point. And second, the potential across each resistor will be equal to applied potential. Okay, of the battery, and the current is going to divide, okay, among the resistor. Like how much current is flowing depending upon the resistance of the resistor, it will be depend. Clear, children? And sum of total current will be equals to sum of the currents of passing through each resistors. Okay, this is regarding parallel combination of resistors. Okay, in this case, try to understand how to derive the relation or effective resistance. Suppose we connected 3 resistors, how to calculate the total resistance in the circuit. In case of parallel, we want to take RP. In RS, the effective resistance in series, we know some of the resistance we got R1, R2, R3 like that. But in case of parallel, how we going to derive? You know that the potential what we supply, that will be equal here. For V1, a potential across the R1 is same, potential across the R2 is also V, potential across R3 is also V only. Okay, that is suppose you take V2, V1, V2, V3 means that will be always equal. V1 equals to V2 equals to V3. They are not not different. It will be all same. But current, you can see what is the total current I is flowing. It will come to this point. It is going to divide into I1, I2, I3 based on the resistance value. Okay, how much resistance, that much current will be through that like that. So by applying Ohm's law, V equals to IR, you know this relation, total current will be equal to sum of all the currents of each slit, and I is equals to V by R, you know. So from that I1, how are we going to write, you know, the triangle again, right children? So this is V and here is the I and here is R. Now we can see the triangle what we want to calculate, I1 we want to find. So we can see now V by R is there. So I is equals to V by R from the triangle. So V by R, since it is R1 resistor, so we can write R1, similarly R2 and R3 we can write. So after writing all this 1, 2, 3, 4, you're going to substitute in the total current relation. So what you will get, I means V by R, total voltage by total resistance, and 1 by R1, V by R1, V by R2, V by R3, I1, I2. So now you take the common V, common factor, both the sides, and again cancel the V term. Okay, what you will remaining, it is 1 by R is equals to this factor you will get. So that effective resistance 1 by RP we call, that will be is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So like this we are going to write this effective resistance in case of parallel combination. I hope this is clear children. Okay, let us see now series versus parallel combination. Series and parallel combination are related. Let us see this table. We're going to understand it easily. First criteria, equivalent resistance. Equivalent resistance will be more than the highest resistance here. Suppose we in the circuit we have 2, 3, 4 resistors. In case of series, the equivalent resistance, what we call no RS, that will be is equals to greater than the 4. So why, let us take some example. If we connected all the R1, okay, let us take 2 and connected in series. So we're going to add what it is R1 plus R2. Right, it's like this, we're going to add 1 and 2. So that time what will happen, it is 4 plus, suppose we take only 2 and 3. So what will happen, 2 plus 3, it will be greater than what? Highest resistance. Okay, 2 plus 3 is a 5, it must be greater than highest resistance 3. So that is what equivalent resistance in case of series is greater than the highest resistor. And in case of parallel, suppose same 2 resistor I want to take into parallel. So parallel means what? P is equals to 1 by R1 plus 1 by R2. Let us take 2 and 3 only connected in parallel, means 1 by 2 plus 1 by 3 will come. Okay, you will take the LCM. Okay, 1 by RP. If you take LCM, what will happen? 2, 3 is 6, 3 plus 2. So that will 5 by 6 you will get. Or if you take the reciprocal, you want RP only, 1 by not RP. So what will happen? RP is equals to reciprocal of the 6 by 5 will come. 6 by 5 children, if you do 1 point something will come. Okay, that means it is not greater than. So effective resistance will be less than the lowest resistance. Here lowest resistance among 2 and 3, which is 2 is the lowest resistance. So what you will get in case of parallel, the RP value is 1.20, that will be less than the lowest resistance 2. Okay, that is what equivalent resistance says that. And the next one, amount of current. Amount of current, it is less than, current is less as the resistance is more. Okay, as the current resistance increases, current will going to decreases the given. And here current is more as the resistance is more. Okay, current will be increases as the resistance going to increase. And switching on or off. In case of this, if one appliance is switched off, all other also not going to work. Suppose we are connected like this in series, no? So one going to off, in the sense here the gate will create, suppose imagine this is going to off or resistance is off. That means here create a gap. If electricity passes, definitely there must be a closed path, right? Here what will happen, here gap is created. When the one bulb is not working, means that here to here gap is created. That means the circuit becomes a open circuit in case of series. That is why it will not work. Other bulbs, whatever number of bulbs are there in this side, then electricity from here to here not passing in, they're not working. Okay, but in case of parallel combination, what we can see, no, it will have one path and the second path and again third path is there. So if one bulb is not working also, it will go like this and come back, and it will go like this and come back. So that total path is there, complete circular path. So current will be flow. If one bulb is not working also, all bulbs will work. That is why this method we are going to use in case of the street bulbs and all, and serials. It's everywhere in the household purposes also we are going to use parallel combination, not the series combination. Next, appliances failure. Okay, if any one stops working, none of the appliances will work. That is the same rule. If one appliance stops working, other will work independently. They don't depend. And potential difference V. Potential difference, that means you know, in case of series combination, potential difference is equals to maximum. Okay, receives the maximum potential difference. Here potential difference is divides, so each appliance receives the less potential difference. So you know that in case of series, what is the potential difference? Current is same, I1 equals to I2 equals to I3. Here I1 equals to I2 equals to I3, but potential, okay, V1 plus V2 plus V3. Potential is going to divide in that equals to total potential. Here what happened potential? Here V1 equals to V2 equals to potential across all the resistors are same equal to applied potential. But the current is going to divide here. Current equals to I1 plus I2 plus I3. I hope this is clear, children. What is differences between series and parallel combination, and now which is more advantageous, parallel combination, not series. Because series, what happen, if one bulb will not working, entire circuit we need to replace. Okay, here we need to replace one more bulb, then only close the path, all the bulbs are not working. If it need to work again, we need to replace new one, like that. That is why we're going to use a parallel combination. Any small bulb is not working, other will work independently. Okay, that is why we're going to use parallel combination for the household and all the electrical circuit purposes. Okay, children, thanks for watching. Keep watching like this.